So traditionally, ships have used compasses to find their way and their bearings, and and these compass bearings rely on the magnetic north and magnetic south pole. Now, the magnetic north pole is very close to, but not exactly the same as true north, or the axis on which the Earth spins, and the same with the magnetic south pole. We also know that there are different influences in the ocean that can actually change the bearing of the compass. So, for example, if there are magnetic islands, for example, the one around Townsville, the compass will not give a true bearing. So, magnetic variation is displayed on the compass rose of a map, like this one here on the left in the corner. So what we'll have is a true north here, and then you can see a magnetic north here. And so in this case, we have a little bit over 10 degrees. Now it's 11 degrees and 18 minutes variation east, and that's going to change by going down 1 annually. So it's 2017 now, and if this was in 2000, it was published, we would imagine that it's just 11 degrees and therefore 1 minute magnetic variation according to this compass rose. So that's one reason why the magnetic maps need to be kept up to date. Now let's have a look at the text. The compass bearings, or degrees on the compass, are affected by local variations and the Earth's iron core. Now those local variations could be things like magnetic island up in Townsville, for example. So islands or places with a bit of iron in them, or magnetite, would of course affect the bearing given by a compass. So magnetic lines running north-south are close to, but not exactly as the north-south longitudinal lines. Remember, our longitudinal lines are based on the axis on which Earth spins. So that's going to be different to the magnetic north and the magnetic south. To convert between the true and the compass bearings, we're going to remember this rhyme. So variation east, compass least, and variation west, compass best. Now you can see that for most of Queensland, the variation, or magnetic variation, will run to the east. I just jumped on Wikipedia and ripped off this map, and you can see quickly how magnetic variation changes throughout the Earth. Here's another one with the Hillsborough Channel. We'll come across this map now and again. Cape Hillsborough, or Hillsborough Up, is just north of Mackay. Beautiful country, and you can see here on the map we've got a magnetic variation there. It's 8 degrees and 0 minutes east, and that's back in 1964, and it's changing about 2 minutes annually. Okay, so it's important to remember that magnetic variation is to the east in Queensland. You can see here that this is our longitudinal line here, but here's our magnetic north-south. So that's the true north up here, whereas that's our compass north. So there's a little bit of magnetic variation that you can see for sure. So let's have a look at a couple of worked examples. Now remember the rhyme: variation east, compass least, variation west, compass best. So we're going to first of all convert the true course to a compass course. So if we've got 156 degrees true and a variation of 8 degrees and 45 minutes east, what do we need to remember? The variation is to the east, therefore the compass is least, or it's the smaller one of the two. So if the compass course is the smaller one, we're going to have to minus it from the true course. And so it's just 156 minus the variation east, to make 147 degrees and 15 minutes on the compass. Now if we've got 209 degrees true and the variation is 10 degrees and 45 minutes west, we need to remember this part. Variation west, the compass is best. That means the compass is going to be the bigger of the two. So you're going to need to add those two together. So 209 degrees true plus 10 degrees and 45 minutes will give you 219 degrees and 45 minutes on the compass. Now let's convert the compass course to a true course. So remember, we're going to just think this a little bit backwards. So 234 degrees on the compass, and we've got 6 degrees and 45 minutes to the variation east. The variation to the east is therefore the compass is smaller. So we just need to say, if the compass is smaller, the true course has to be bigger. So we're going to add the variation on. So 234 degrees on the compass plus 6 degrees and 45 minutes variation will give us 240 degrees and 45 minutes on the true course. Now if we have a look at 25 degrees on the compass and a variation of 10 degrees and 45 minutes to the west, we remember the variation is to the west, the compass has got to be the bigger of the two, therefore we go to minus to get the true course. So 25 degrees on the compass minus 10 degrees and 45 minutes variation will give us 14 degrees and 15 minutes true. So today we learned to convert between the true bearing and the compass bearing depending on the magnetic variation. Your work now is on page 268 of your textbook, and that's exercise 5D.